Alright, so today, from here on out, we are going to be dealing with triangles. If they are right triangles, we can use these. Does that make sense? If they are right triangles, we can use sine, cosine, and tangent. But if they're not right triangles, and no Pythagoras theorem. Can I say that again? You cannot use Pythagoras theorem on this one. Cannot. It has to be a right triangle. Okay, first of all. And second of all, you cannot use those. You can't use those. So you need new formulas. Okay, and that's what we're going to learn this week, are the new formulas. So let's start off with number one. Before I begin, your book gives you, and if you like formulas like this, awesome. K equals 1/2 AB sine of C, or 1/2 BC sine of A, or 1/2 AC sine of B. That's okay. Some kids like that. Me, I think it's better if you see it in context to the problem. So you're going to need an angle. Area of a triangle you're going to need. So area of a triangle you're going to need side, angle, side. Yeah, SAS, which means side, angle, side. You have to have that in order to find the area of a triangle. In this example one, I have that. I've got my angle and the two adjacent sides. That's side, angle, side. Okay, you have to have that. This formula will not work unless you have, Carly, what? 3 things. Try. Always have to have 3 things. There's your try, right?
Yeah.
You cannot solve any triangle problem without 3 things. Okay, so if you have an angle, if you know that angle, and you know the 2 sides next to it, the side, angle, side.
Angle, side, side.
Yeah. Yeah, we will actually talk about that one. Kai, remember that?
Yep, I do.
We will do that again because, yep, that's right. Yeah, we'll talk about that on Wednesday, okay? We're going to talk about that Wednesday. So what's important on this is that you need 2 adjacent sides. In my example, I have the 9. That's an adjacent side. I have a 10. That's my other adjacent side. Now we can't call it hypotenuse or opposite or any of that because it's not a right triangle. So you have just adjacent. They're both next to it. Does that make sense? Next to it, the angle I know. Here you are. You're standing here. Standing next to you are your buddies. They're right adjacent to you, okay? That's the opposite. Okay? No hypotenuse. So the formula is this. 1/2 the adjacent side times the other adjacent side times the sine of the angle. That's it. It's a really easy formula for the area of a triangle. Okay? So example 1, this triangle is easy. The area of this triangle is just area equals 1/2 9 times 10 times sine of 40. And I will stop for a second because I'm going to say something. Vince, I want you to say, Mr. Davies, does it matter which one's adjacent 1 and adjacent 2?
Mr. Davies, doesn't matter what's adjacent 1 and adjacent 2.
Good. You didn't even ask the question. You stated the fact. It doesn't. Does it? Doesn't matter? Here's a 1. Right? Perfect. Does it matter?
No.
No. Okay. Thank you. You're right.
My bad.
No, perfect. Okay.
28.
LOL.
Yeah. So we just use our calculator. Make sure you're in degree mode, right? You have to be in degree mode. Remember your mode. If you're in radian mode, you're going to do everything wrong. So I'm going to go 1/2 times 9 times 10 times the sine of 40. And the area of this triangle is about 28.93, okay? And that's in terms of centimeters squared. Okay? Everybody agree? Pretty easy, isn't it? Okay, example 2 is more of a pre-calculus problem. Oh, that's good because we're in pre-calculus, okay? So we have the area. We have the area, and we have angle. We have side P and side Q, and it says find the measure of angle R. Okay, so let me just draw a triangle for the heck of it. Just get a picture of what it looks like. Okay, and I've got. I want to find angle R, so angle R is there. I've got. That's R. Let's make this be angle P, an angle Q. You all right with that? So therefore, if I do that, then I know that side P would have to be here, and side Q would be here. Okay. I mean, if it's angle, capital letter makes the angle small. This is little q, and this is little p. So it's opposite the angle is how we label. Okay. All right. Well, I can figure this out. I know the formula I just gave you was this. Hold on. What did I do with my pen? Draw them down. I can't find them half the time. All right. Just use them. Here it is. So my formula was area equals 1/2 my adjacent times my other adjacent times the sine of my angle, right? This is like playing Jeopardy. I know the area. It is 15. My adjacent's 10, my other adjacent's 5, and I need the sine of angle R. All right? So I know the area, I know the answer, but I don't know the angle. Well, I can do that. All right, so I'd have 15 equals, well, that's 50, but half of 50 is 25. I'm just going to divide by 25. What is that, 0.3 maybe? 15, 25 is, no, 0.45 I'll bet, huh? 15 divided by 25, I got 0.45. No, 0.6, boy, I can't do anything right. 0.6 equals sine of R, right? And then how do you find R? What's your angle button? Remember what your angle button is on your calculator? Yeah, so we get to fit the inverse, right? So we're going to go sine inverse of 0.6 equals angle R. All right, so sine inverse of 0.6, and I get about a 36.89, or we'll round it up to 36.9. How's that? We'll round it 36.9 degrees, okay? Now here's, believe it or not, here's there's another question. There's two triangles. What? Two triangles. Oh, it could be the dreaded angle side side, Kai. Because there is another triangle that might look like this. That might have the exact same area. Do you see how those two might have the same area? It's possible, isn't it? It's possible those two could have the same area. If you set up, so think, I want you to think. If you set up the formula with this triangle, it's the exact same formula. If you set up the formula with this triangle, it's the exact same formula, you get the exact same answer. That angle's not 36 degrees.
No.
Come on, think, how would I get this angle?
Oh, so
Minus
is 36 like on the other sides? And it's
50
just,
off.
It's right
So
there.
it's
Yeah, you remember that?
Yeah.
You paid attention during COVID.
I did.
You must have.
I did not.
Not many people did.
I do not.
Okay. So Carly, that 36 is also right there, isn't it? So Kai, you were saying subtract from?
180.
Yeah, so the other angle could be 180 minus the 36.9 degrees. And let's see, we go, okay, 180 minus 36.9, about 143.1. Okay, how am I doing? Good. Okay, example 5. All right, let's see if I've got my fancy templates. All right, I'm sure somebody's going to want to borrow my fancy templates, but let's see what this problem's all about. I got a pentagon. It's a regular pentagon. All right. And it's inscribed in a circle. Oh, that's the wrong size. There we go. That's the size I want right there. Okay, anybody want to borrow this? Yes, no? There you go.
So that looks
I can freehand it.
That just look cool.
It does look nice, doesn't it? Yeah. So the circle has a radius of 6. And that's all we have. That's all we get. So we're going to find this area.
I will borrow.
No, 20 miles per hour too. Okay.
You can use either.
I think so.
Yours is awesome. All right. Well, anybody have any ideas besides me?
Nope. You taught it, but I forgot.
Ellie, what do you see?
If it's going straight through the corner, then we can form a triangle with both sides of 6.
Yeah, because it's a circle, right? Nice job. It's a circle, so the radius is 6 all the way around, right? You guys agree with that? And since we are doing trigonometry, hey Carly, what does trig mean? What does tri mean?
3.
Right. So let's make some triangles, huh? Triangles. Well, there's 5 of them, but we do have a formula. We really do. We got a formula on triangles, don't we?
Yes.
So I'm going to take this triangle here and draw it down here, okay? Just make it bigger. So 6, 6, okay? All right, so far so good. Good job, Ellie. Now what? We got a formula. We just learned a formula, didn't we?
Yes.
What's our formula? 1/2 adjacent times adjacent. We need this angle.
So would you use 360 divided
Oh,
by 6? No.
divided by 5. There you go. Yes. Everybody agree with Lauren? Yep. So let's find the central angle. 360 divided by 5. So we'll call theta is going to be 360 divided by 5, which I think is 72, isn't it?
Yep.
So that angle's 72 degrees. Okay, now it's getting easy. Because we don't have to. Now, you do not have to break it up into 2 triangles. You don't have to. It's just 1/2 6 times 6 sine 72. It's just 1/2 6 times 6 sine 72 because that's our formula, right? So our formula we just learned on area of a triangle, right? It's that one there. So we're going to go, the triangle is 1/2 6 times 6 sine of 72. All right, see what we got. Okay, 0.5 times 6 times 6 times the sine of 72. And that's one triangle, right? Now what are we going to do? That one triangle? Yeah, so my pentagon will go 17.119 times 5, right? Because there's five of those triangles. I get about an 85.6. That was pretty easy. You guys agree? Once Ellie gave us the hint, we got it. Okay, ready to turn the page? Let's do some pre-calculus. Because this is just algebra 2.
How about
This is just algebra
how about
2.
we keep doing it?
This is algebra 2. Let's do some pre-calculus. All right? Find the area of this quadrilateral. Okay? Anybody have any great ideas?
Make 2 triangles.
Yes, Vincent, yes. In fact, I really want to do this one because I like the 90. You guys agree? I like the 90. So I've got triangle 1, and I've got triangle 2. Nice job, Vincent. So area, triangle 1, that's easy, right? Because it's a right triangle, it's just 1/2 base times height. I can do that, right? I got that. I got this one down. So triangle 1's easy. 1/2 10 times 7. Kai said 35. I'm going to circle that because I want to come back to it, okay?
Wait, how do you determine what's like the base and what's the height?
The base is.
It won't matter. Good question, because if I turn the triangle like that, it doesn't matter, does it, Lauren? Right? You see that? Yeah. Good question. Now, what about triangle 2? We need 1/2 adjacent times adjacent times the sine of theta. Okay, we got some work to do. What's one thing you can find?
You can find that top angle by doing the math when you, because you have that right angle triangle, so you can find the angle there and you can subtract that.
Yes. Can I do something first? Yes, I'm going to do that. Yes. We're going to do something a little easier. Nice job. We're going to do that stuff. Ellie, what do you see?
Could you find the angle with the right triangle right there and then find,
Right there, right?
yeah, and then subtract that from 115 to get that angle?
Yes. So Lauren said both you girls are thinking. I like it. Give me something. Yes, we're going to do that. I
Wait,
don't want to do it yet because there's something even easier to find.
You can
Okay, what do I need?
Adjacent sides.
I know that 13. What don't I have?
Hypotenuse.
The other.
Oh, right triangle.
And because it is a right triangle. Boom. You're awake today, aren't you?
Oh, yeah.
Oh, yeah.
Oh, yeah.
Let's call that C. So I've got 10 squared plus 7 squared equals C squared, right? Nice job, Vince.
Yeah.
10 squared plus 7 squared, right? I'm a square root of 149. So I get an answer about 12.2. Okay.
Can make me feel a little bit crazy too.
Okay. So put 12.2 right there, 12.2. Now I'm going to do what both Ellie and Lauren said. Let's do the hard stuff now, okay? So if I call this angle theta, I'm just going to call, don't let this freak you out, I'm going to call this angle alpha, okay?
Oh my gosh.
You're going to have to start getting used to this kind of stuff because you're going to start seeing higher math. Theta and alpha. So what I heard is through right triangle trig, I could say that tangent of theta is equal to 10 over 7 because we have a right triangle, right? So I've got from theta, I've got my opposite over adjacent. Elise, how do I find the angle? What's our button? Inverse. You guys remember? Inverse button. So we need to find the angle. Thanks, Elise. I picked on you, didn't I? But I knew the answer. Tan inverse of 10 over 7. 10 inverse 10 divided by 7 is about 55 degrees. Okay. Now, Ellie suggested then to get this alpha, we're going to take 115 degrees minus my 55 degrees will give me alpha, right?
It's okay if you.
So I get about 60 degrees.
That's a poster in the middle school. Yeah.
And now I'm going to use my new formula to find triangle 2. So triangle 2 is 1/2.
Wait, hold on just a second. What angle is 55 degrees?
Good question. I should write it in there.
The one on the right triangle on the opposite side.
Oh, okay.
Here you go. Thanks, Carly. Thank you. And that looks like a 6 degree, not a 60 degree. So, that doesn't look very good. 60 maybe. So I'm going to go 1/2 adjacent, which is 13, times my other adjacent, 12.2, and I'm going to use sine of 60 degrees, 0.5 times 13, times 12.2, sine of 60, and this will give me the area of triangle 2. So triangle 2 is going to be a 68.7, we'll go 68. Circle that. Total, put these two together, 35 plus 68.68. Wow, that's lousy handwriting. 103.68 centimeters squared. Okay, so we've got time. You have about 18 minutes to get something going. I know you can do this. If you get stuck, ask me. If you need a mass break, you can run out in the rain real quick if you need.